Thanks for coming to the last session on the last day. I'm Katie Voss. I'm the librarian for Journalism, Media, Culture, and Communication at New York University Libraries. And I'm a curator there, so I got involved in this related to a kind of a curation issue. And I'm presenting on behalf of our research team. There are 3 other folks on this team, so I'm speaking for kind of a lot of other people who are doing other very important parts of this research, so I'm going to rely heavily on my notes when I need them. But some very important folks who contributed to this. Ilya Kreymer, who needs no introduction here, the lead developer of Webrecorder. Rémi Rampin is the lead developer of ReproZip, and also Vicky Rampin, she was also on this grant project. And she is our, I'll make sure I don't get her title wrong, she's the Research Data Management and Reproducibility Librarian at the NYU Libraries. So all of us collaborated on this project together. So the grant is called Preserving the Dynamic Web. It was funded by, very generously funded by the Institute of Museum and Library Services, which is a national agency, government agency in the United States. And it's a collaboration between the New York University Libraries, New York University IT department, which was originally the Center for Data Science, and Webrecorder. So this has been going on for about 3 years, and we're just wrapping it up now. And our work has been centered on UX testing and development. So actually the IMLS funded this twice. They funded sort of a planning grant for us about 5-6 years ago. And so this was really to bring our prototype into production. Okay, so I don't have to spend a lot of time on these next couple of slides, but just, you know, some of what we're going to talk about here. I guess I should preface this slide by saying ReproZip-Web, our tool, is really useful and designed for kind of a narrow slice of the web. It's very high fidelity web archiving that archives dynamic server-side components as well as the front end of a website. So this is not web archiving for like tens of thousands of things. This is web archiving for like a very advanced DH project, a website that is like very important and precious, you know, to somebody at your university or your institution, and you really need to get the whole thing in order to capture the look, feel, and the functionality. The type of website we're targeting, what are the issues with it? You know, they're very hard to maintain. In order to maintain a live site like this, you know, you have to have the time, the human resources, the funding for the servers, the interest and involvement of the original authors, all of which does not last, as many folks have found out. And the archiving options are very limited. Even dynamic web crawlers like BrowserChicks crawlers still cannot capture some of the functionality and the server-side components that these websites, database-reliant content that some projects depend on. Is there anything I'm forgetting here? Yeah, so there really hasn't been a great archiving solution to archive everything together, like a database with the front end of the website, until now. So, I guess this is a little bit of kind of just a diagram of why it's kind of difficult to archive something with a complex architecture of a dynamic app like this. You know, you might have a database or an application. You have, of course, the web browser that's displaying everything. External APIs. There might be external APIs that make everything even more difficult that then our tool can't even capture. So there's always another level of unarchivability waiting above us all the time. Yes, but we can get the server-side components. These are just some examples. These are some different DH projects that have aspects of the site that can't be captured otherwise. This is kind of a cool, the world of Dante project by the University of Virginia. I think everybody's kind of familiar with examples like this and has seen them in their work. Okay, so how does ReproZip-Web address this problem? So this is kind of the workflow, and we'll get into this in more detail in a minute. But so it's just basically a mashup between ReproZip and Webrecorder. And I'll take a second to touch on ReproZip a minute. It is initially a tool that was, I think it's been in development for about 10 years. It was started at the NYU Center for Data Science in order to address computational reproducibility. So the ReproZip part is designed to pack and make reproducible like huge computational experiments, astrophysics experiments, things that have a tremendous amount of data behind them. And if you want another researcher to be able to rerun your experiment, you can pack it up with ReproZip. These never really required like a front-end interface or a website before, but since this was also happening at NYU when me and some other researchers encountered this problem, we were like, oh, maybe ReproZip can help with this web recording, this web archiving problem that we're facing. So ReproZip captures, does the client-side capture, and then we combined it with Webrecorder ReproZip captures the server-side capture, and we combine it with Webrecorder, which does the client-side. Am I forgetting anything? Oh yeah, so the software has 3 steps to create a fully archivable bundle. It's trace, pack, and record, and then 1 replayable step in the browser. The output is an RPZ file, which is basically a fancy tarball that can be full extracted in order for the contents to be examined in depth. So we're going to start with the tracing step. So the first step in using our tool is to trace the app. So you use ReproZip to capture the backend assets. This requires a Linux operating system for setup, and you also need access to the app that you want to archive. This is one of our limitations, which we'll talk about in a minute, because that can be very difficult to get that access. So first we execute ReproZip at the same time that you run the dynamic app. So you have access to the app, and you run it, and then you execute ReproZip. ReproZip uses ptrace, an internal Unix system utility that lets one process, ReproZip, observe and control the execution of another process, the app. So ReproZip notes down everything that the web app touches as it executes into a SQLite database, and then it is used to create a configuration YAML file with a ton of administrative and technical metadata about what happened during the web app's execution. ReproZip will then trace and record what version of which software was used, what operating system was used, and the input and output files, and provenance of what runs in what order. So you can edit the config file before the package is created, but generally our engineers discourage that because it can affect how the app runs later down the line. After tracing, you use ReproZip again to pack the web app and all its dependencies into the RPZ file. Once we have the initial capture of the backend assets with ReproZip, we then upload the RPZ file into ReproServer to do the recording step and the front-end capture of the assets. So, and then following the wizard on the ReproServer interface, users get to a page where they can choose between automatic and manual recording. And at this point, I'm going to hand it over to Ilya.
Yeah, so with the system, there's a component called ReproServer, which is a server API for unpacking these RPZ files. And so essentially what it does is the server runs a particular RPZ file that is a web server. So it basically unpacks the web server from RPZ file and executes it, because that's the reproducibility portion. And then we insert archive web page at the beginning. And essentially what archive web page does is it routes traffic based on, so if a URL is coming from a designated server URL, it routes it to the repro server. Otherwise, it loads it from the live web and then creates a WAC file. And so this allows us to essentially combine resources that are running on this emulated server with other resources that are coming from the live web, and then only store the ones that are coming from the live web into a WAC file, and then they're packaged. So we take the WAC file, send it back to the repro server, and then it produces this RPZ plus WAC bundle, which is using the RPZ tarball. We basically just add a WAC file, and I believe some additional metadata is added there. And then for replay, the idea is that it's a fairly symmetrical process. We have a replay web page that it's configured in such a way that it checks for a particular URL. I have it my web server.example.com. It could be in the creation of the system. You would configure what that URL is. If it's the designated server that's being emulated, it routes it again to the repro server. Otherwise, it loads that data from the WAC file. So it basically intervenes the regular replay from the WAC file has this extra component where it routes to the live server. And yeah, essentially what that allows for is if there are any dynamic, for example, search queries or other things that interface with the database that's being emulated in repro server, those could still happen, and because this is a real web server that's running here, and everything else is loaded from the WAC file. And so the input for the system is the same as the output for the creation of it. We take the RPZ file, it runs the server from the RPZ and unpacks the WAC, and then the replay heads out. But yeah, and so that's and the interface for it is still a replay web page on the front end. Then I'll pass it back to you.
Thanks, Ilya. Okay, so I think we had a great conversation about this earlier, about like what archival tool to use for any specific website. It's really not very clear. Hopefully that'll be coming imminently, but we also reference archiveready.com. That's a good place where you can check. But ReproZip is very useful if you have these server-side components and external front-end assets. So, quick example workflow. I'm going to rush through this, I'm sorry. But this is like the DH course registry is a website that's still up and running. And we just use this as an example. We have some screenshots. This is how it's built and what it does. And so step one, you acquire and run the app, download the source code from GitHub, read the documentation a lot, create a VM so you don't break your computer, and then start the app and see if it's working locally. And then you run ReproZip trace. So prepend the ReproZip command to see how the app would run originally. Run it as normal. You can open up and kind of check that, double check if you want while you're tracing to make sure you're getting all these different components. Step 3, pack the app with ReproZip. So let me make sure I'm getting, at this point, once you pack it, you pack the file into the RPZ file, running that command, and then you can see it in the browser. And at this point, you should have the server and all the computational dependencies. Okay, and then you get your RPZ file, which then you could replay on Repro server. So you can do a manual or automatic crawl, interact with the site as you want, and then you click, there's kind of like a wizard that takes you through, and you click end recording, and that's gonna put your WAC inside. And then you can replay wherever you want, from wherever you want. And then you have a single archivable, preservable, distributable file that you can also add to like your institutional repositories, etc. Okay, why do we like our approach? It's flexible. It supports like a lot of different archiving approaches. It's we try and make it straightforward. It's hopefully straightforward. Honestly, though, in practice, it's not. Depending on the age of your app, nothing is straightforward, right? But we're trying to make it pretty straightforward. We like that it's using standards. It's using the WAC standard for web archiving. RPZ is a new format. that we're, hoping with the test of the community, everybody would find useful. It's simple, generalizable, effective, and it's a complete capture. I guess this is why we like it the most, is you're able to completely capture an app, hopefully that somebody could run 100 years from now. You have to have access to all the servers where the app is deployed and hosted. Oh, that's a big challenge, especially for digital archivists, who are often getting these things from donors and they're not fully complete. Technology, you do have to be, you have to have some technological capabilities to run the command line for the tracing and packing, and you need to know how to start the app, so that can be a challenge. And the site status, another big one. If the site is already broken, this ReproZip-Web, I can't help. There's nothing we can do, unfortunately. I'll just skip over this side. Thank you so much.